check it up on your micrometer and make sure that it's reading the same as it was. Um, and you get into honing. Well, on honing, first off, the trick with honing is you want to, and I guess it ain't really a trick. You want to have a bore that when you're done machining it on your boring bar, um, hopefully it's going to be the same from top to bottom. In other words, when you get done boring, you don't want to have a thousandths taper already in the bore. That makes things hard. If you can bore it and you can keep it straight from top to bottom, honing it's a lot easier. Now, you can leave 5 thousandths in the under the bore to hone in, and a lot of guys do that, and I do too. Some blocks move more than others. You can get into a situation where if you have more material to take out, you want to take that out with your coarsest stone to a point without getting into profiling and profilometers and what grit do you use with an engine that runs on alcohol versus an engine that runs on regular fuel, and is it a nitrous boosted application? Are we gonna leave the walls a little bit more of a profile on them to hold oil on the cylinder walls as a stroker? Do we want the bottom of the bores to hold more oil to reduce the friction in the shearing that's going on? So there's a lot of information to unpack there, and not going to do that. I'm just going to tell you how to successfully keep the bores straight when you're manually honing. Now, disclaimer, this is what works for me. This is what always has worked for me in the past. It's working for me right now, and I have no plans of changing into this. Now, what I have changed is I have changed to diamonds to rough out the bores. And the reason being is sometimes, like Dart and some other companies, their cylinder walls are pretty tough. They're a better grade of iron than, say, this stock block is. Most of the cases that's to be true. And diamonds don't break down as much, and they're a little bit more robust. And I'm going to keep saying that word till I get it right because I'm not going to edit this. But they break down differently, they handle differently, and the explanation that I'm going to give you sounds kind of corny, but it's like running down the hall in a school with granite floors and a pair of church shoes. That sounds kind of funny, but the difference between vitrified and diamonds is that diamonds seem to be harder. They feel differently in the machine when I'm running it manually. Now, you might not feel that or sense that in a CK10, but with these manual machines, there's a fair amount of input coming back through the head into your hand. At least for me, there is. So the vitrified stones usually break down and they're softer. It'd be like running down the hall in a pair of gym shoes compared to a pair of your good church shoes, let's say, go to town shoes. So they handle a little different and they act a little different. And you got to be careful with the diamonds because they take off a lot more. And you got to monitor how many passes, you pump the head up and down, say 5 times. Or stroke it. I'll probably say stroke and pump and be using them the same terminology as I talk through this to you if you don't fall asleep. Now, I will go, say, 5 times, and then I'll measure, and then I'll check it. And then I'll see how much I've taken off. Okay, say I pump it up and down, stroke it 5 times, and say I don't take out nothing. So, okay, I increase that to 10. I go up and down 10. And depending on how much pressure I put on the head, because the stones advance out with the amount of pressure, and me personally, I want to run the stones as hard as I can without stalling the machine. So I want the stones to be pressing on the walls, and I want as much pressure as I can get on this head to advance the stones without having them bog the machine down. There's there's reasons for why I do that is because if you don't, you can end up with an egg-shaped hole. Um, Usually with this type of machine, you're not going to put enough pressure on the stones to deform the cylinder wall. Although, as the pressure increases, so will the friction and so will the heat. And that's another thing too, is when you go with your stones, I use roughly most of the time 3 different stones. I use a coarse stone, which is a soft bonded vitrified stone, and you can go through Goodson, and I'm not saying you should buy your stuff from Goodson, but you can look in their book and they have a explanation of the compound, the bonding agent, basically the grit, and how it's intended use, whether it be a short stone, which is on here. These are short stones, and it'll get into a long stone, which them are. It'll tell you whether it's good for hard material or soft material. Now, usually on stones, the soft material is for a harder sleeve or a cylinder wall, depending on if it's been sleeved like a diesel or if it's just a iron aftermarket block like a Dart, let's say. What happens is the bonding agent will let the stone break down faster and it'll stay sharper. Now, that's my opinion. Somebody else might tell me that makes stones for a living that I'm wrong, but that's the way it seems for me. So that means that the softer stone's it's gonna break down and it's gonna stay sharper, and it's not gonna glaze. So I use, most all the time, I use soft bonded stones for hard sleeves with the manual machines. They don't load up, they don't glaze. It's really hard to glaze a soft bonded stone. Now, they break down faster, they wear out quicker, you have to buy more of them. Yeah, that's the problem. But I would rather have straight up and down cylinder walls and have to buy more consumable products. That's the way that goes. Now, with the diamonds, going with a coarse diamond, they don't break down, they don't really have much taper, and these stones can get taper in them. You can dress it out with a coarser stone, and I do that. And then I've talked before about the wipers, measuring the ends of the wipers and taking I use a body file, and go over it and flatten them out and square them and measure that and make sure that they're square. Having a nice flat stone, getting full contact all the way up and down the bore is key. If the stone has got waves in it, it's not going to cut as accurately as a full stone with a flat surface. If you think they're getting glazed up or they get material in them, you can rub them together. I've seen guys do that. I've done that. You can also dress them completely. But anyways, getting back to controlling the taper in a cylinder wall. If you got choke in the bottom, and that's what I call it, choke in the bottom of the bore, you can use a short stone. Now, you want to take and control. You want to get all your taper out. If you're honing and the thing's going sideways, walk away, let it cool down, make sure you're not putting too much heat in it, walk away, and then see where the taper is. And if you get a lot of choke at the bottom, you'll want to use a short stone like this, and I profile them so this is the widest part of the stone. And usually if you get choke in the bottom, it's usually the most of the times I see it like in a big block. You'll see like big block Chevy. You'll see like 3/4 of the bottom of the bore will have a little choke in it. Now, depending on how much choke's in it, depends on a lot of things. But if you've got a perfect cylinder wall up and down and you can't get the choke out of it, and you're already on your target size and it's pretty much finished, a half a thousandths down at the bottom where the rings don't travel is not the end of the world. Now, I like to get them below that, but some blocks are fussy. Some blocks are just fussier than others. Basically, put it in a nice way, a pain in the ass. Some blocks can be a perfect pain in the ass. You can get hourglassing in the center of the bore where there's more choke, or you can get beer barrel where there's choke at the top and choke at the bottom. Well, choke at the top and choke at the bottom requires two different stones, in my opinion. And that is a short stone that's profiled like I've got. You go down there and you work out the bottom and you work up the top, and you overstroke the top. That's just the way I do it. You want to take care of all your taper, and you want to get everything as straight as you can before you're doing your finished stones. Now, you want to do, I do that kind of intermediate. You know, if the bore is straight and I've got it all roughed in and I hit the stones, my intermediate stones, if they're nice and true, chances are I'm going to get nice and true from top to bottom. If you get into a situation where you get a lot of choke at the bottom, um, you'll have to go in there with a pair of short stones. And I've modified stones. I've taken stones and I've cut them down so that they're just like 3/4 of an inch down at the bottom. But you want to make sure that when you do your boring and your honing, that you've relieved enough of the bottom of the block without breaking through the oil galleys like on a big block Chevrolet. You don't want to run the boring bar down any further, but you want to run it down far enough that you clean up the rest of the residual left of the old bore, because your stones will get chipped just like them. And I'm hard on stones, and you know, I crack them, I break them, I chip them. That happens. Sometimes it's just part of the game. I don't, you know, I don't like it, but you know, diamonds seem to take a little bit more abuse. You want to make sure your positive stop is adjusted, of course, on your machine, and this one does have one. So is my other machine. So you work at the bottom of the bore, you get that choke out of there as much as you can, although the rings aren't traveling down there, you know. And say on a forged piston engine, you're at 5 thousandths piston to wall clearance, and you got a half a thousandths worth of choke down the bottom. Chances are it ain't going to do nothing, but you know, if you want to go down there, you can use a shorter stone and make sure that the machine is going down far enough that you're not hitting one part of the stone all the time, because if this part of the stone is undersized, well, then you're never going to get that taken out of there. You're just basically essentially running the stone down, pulling it up, running the stone down, pulling it up, and that part of the stone, or the honing stone, is never going to open up the bottom. You're going to open the top up, but you're not going to open the bottom because this is already undersized. So you got to kind of watch all this stuff, and I monitor it with my sundial bore gauge. Like I said, as far as I'm concerned, that's one of the best dial bore gauges for this job. There's a lot of reasons why guys buy very expensive hones that do a lot of this work, is because I feel that this is a skill, maybe even an art. And to get cylinder bores perfect with a manual machine, I've never had an automatic, but from what I've been told, they'll read the cylinder wall. And, you know, like I said, I'm not going to get into profilometers and, you know, the finish on the bores and what finish you should shoot for. I've been doing this for over 20 years. I do them the way that I believe works for me. We've checked a couple of blocks, and of course, every block's going to be different. I don't have a profilometer. Will I ever get one? Well, I may, but chances are I'm not going to get a $85,000 plus honing machine too. But this takes time to do it this way. Usually what I do is I rough them in, and I get them up within, this one right now is within 1.5 thousandths top to the bottom, with less than a half a thousandths of taper at the bottom. I'll let this set overnight, and then I'll finish this side. I'll take the rest of it out with the finished stone. and I'll roll it over and I'll rough the other side in and let it set, and I'll finish it up. So you're talking more than 1 day of setting. I could probably do it in less than a day, but if you leave 4 to 5 thousandths in, that's kind of how I do it. I've got 2 honing machines, so I can, I still can get 2 blocks done in a week, but that's a lot of manual stroking on these machines, and it gives you a hell of a workout. Um, so that's kind of what I wanted to say. Getting back to the machine, a couple guys commented on it, and basically the machine, yeah, I built it and I made everything on it. And when I mean everything, I mean pretty much everything. There's a few things that I bought through surplus stores and eBay and a few other places, but the U-joint up here, I honestly don't know where I got that from, but I think I might have got that off of eBay. This collet here I made, there's a 90-degree shafting system in here. I bought that off of surplus. In here there's a step-down unit, and then in the back there's a motor. And why I did this one this way is because it's got a counterweight on the back, and it's pretty simple. But actually the machine is somewhat balanced. So with the axe machine, we'll go over and look at the axe. The motor's up front, right in the head. And this machine, when there's no air on, because it's air assisted, you can barely lift it. And it's hard. And of course it's got a heavier and light control on it. But this is basically the same honing AN, Sun and AN style stones. This has got a hand wheel on it. So that means I can advance the stones on a fly, which is kind of nice, but it's, it's not the end of the world. Now this one's got a fixed table and it does not move this way and that way. Now mine, so I can get a better arc sometimes. If you're watching, sometimes if the taper is getting a little funny, sometimes, this is my speculation on that, is I can move the table so when the head's all the way down, it's a straight shot, The U-joints in here, and then the head swivels on a pivot point. That takes out some of it, but it's good to have the head run as straight as it can up and down the cylinder bore. Now this is just a semi-oil filter, and I put this in a few years ago after I built the machine. I wasn't getting a lot of grit coming up through here, but it helps. And the stones, there's a tray under this machine, and I believe I might have put a baffle in it, but if I didn't, I probably should have. But I use a filter mat in both machines, and that keeps some of the major grit out. When I get done boring them, I usually wash them down with mineral spirits. And I blow them out, and I make sure there's not a lot of remaining grit on the block. This machine should have a cover on it. It's right next to my mill. But I don't do that many milling jobs, and I don't run the machine at the same time. I'm just not in that big a hurry. Now the other one's all the way down to the back of the shop. And that's by a milling machine, but it's one of them deals. In a perfect world, I should have a cover on both of them, okay? But my oil is fairly clean. I don't get any grit in it, okay? Now, the axe machine has got what they call a rope filter in it, which is essentially, it looks like yarn wrapped around the tube, and that gets filtered through that. These I can go down to the diesel store, this truck store, and I can buy that filter and I can throw it on there, 2, 3 of them. But what I was getting back to is on the tray underneath the machine is usually the grit kind of coagulates and sticks, and it ends up being like cement. So I haven't cleaned this machine in probably a year. I haven't used it a lot lately. I've been using my axe more than this machine. This machine was a good machine when I had it because it was the only machine I had, so it did the job. There's things about this machine that I like more than the axe machine. This I can control the speed of the head, so basically I can control the stroke a little bit. I can control it by the controlling of the speed controller, and I kind of like that with this machine. This the one over there, it runs at the RPM that it runs at, and you have to move if you want to try to achieve the crosshatch that you're going for. This machine's a little harder, a little easier to control that. Excuse me, a little easier to control than the axe. And I got the table where I could move it. Is that a big deal? Well, it helps, I believe. If I was to build another machine, would I put it in there? Well, basically this machine, how it came about is that machine down there was available, but it was not available soon enough for me. So I took the measurements off this machine, roughly, and I built my own. Now, I did a few things differently, like the head, and if I had to do that head all over again, I'd exactly do it the same way that I did mine. This air assist, with mine, it's not an issue. It's just it don't come up because my machine is perfectly balanced without the air assist. So that means, there might be a little bit more resistance pulling it up or pulling it down. But with that machine, you got a choice, and it's really hard to. I've got that machine, the axe, kind of in a neutral position. If you want it to stroke easy up, you got to push harder going down. So that machine, if it had somebody asked me, well, you could make it stroke and you could make it automatic. Well, yeah, I'm not going to get into that. I mean, when I built this was enough work for me for a while, and I didn't really want to get into a power stroking situation, which maybe I could have did it. Instead of making it run on a rail like the axe has, I went to linear shafting. I thought it would be easier. It's stable. I mean, you really have to gorilla to get any flex, but they flex a little, but the machine comes back, and the axe, it has a problem with the trolley that it runs on, or the rail that it runs on, is you can adjust the wheels, but they put holes in this rail here, and the ball bearing bangs on it, and it kind of wants to stick. There's a large coolant hose underneath the machine, and it isn't as free as it could be. I put a new hose on it. That helped. I moved this wheel up here, and that helped. My machine's smoother than this one in that respect. This has got an adjustable table on it, so this angle can be adjusted. I always try to put them at a level, but on this machine, and particularly on this bank here, sometimes I'll angle it in favor of not having the U-joints in the head at a steep angle. So I'll move it, the head, I'll lay the bank back a little bit and adjust it. So this one has an adjustable bed on it, if you will. Mine, when I did mine, I just simply put a notch for the table straight up, and then one here, and then one on the other side, and I just pull that up, move it, and it drops down into detent. And that's just an Allen head bolt. Now, if you get crazy, sometimes it'll pop out of the detent. So when I made the detents, it's half the distance of the diameter of the Allen head. I should have made them deeper. But I didn't, and that's one of the faults of this machine. I can't straighten the angle out or move the angle of the deck with this machine, but what I can do is I can move the table back and forth in the machine. And then I have a lock here that I made that I locked it. Now this up in here is on linear shafting, and this has got a tube on it with linear bushings in it that travels up and down the shafting of the machine. Now down here I've got some wheels on the bottom of these. I don't know if you can see it. There's wheels down there on each one, and it rides on an edge of a piece of angle iron, 1 inch, and then I bolted that to the table. And when I first built this machine, it leaked like a sieve. I caulked it. The silicone didn't care for the oil, honing oil, but basically over the years, with all the grit that's come off the stones and the blocks, it's pretty much plugged itself solid. So it's kind of like a it's kind of like a cement. So it doesn't leak like it used to. Still, honing machines are a little messy, but I mean, I've got a tray under there, a drip tray, oil pan, whatever you want to call it, and I got a little giant pump in there, and it's pumping up in here, and I've got a control valve on it, so I can open and control the volume of oil. I've got it running pretty much wide open. That's kind of the way I like to run it. I like to flush the cylinder walls. I don't like working in the slurry. But yeah, that's kind of it. A couple guys asked about it. Not a lot of people, and that's kind of the story on the machine. Of course, I put a halogen light here because I wanted to have light down the bores of the engine. The axe doesn't have that. Of course, you could put that on the axe. It seems to help a little bit, but it's not one of them have to have it. If I had to do everything over, there's not a lot of things I would change on this machine, because the height from the head to the block, this could be higher, and I was going to make a riser here and move the head up higher on the machine and put a different head on it. I have a different head. I have a diamond head for this machine. Don't think that's going to happen because I bought some AN stones, and for what I'm doing so far, these machines work good enough that I don't plan on changing anything. If there was going to be a major change, I'd probably buy an old CK10 or something. But for the most part, these things work. It's just you have to have a little effort doing it, and it can be tiresome. Well, I hope you get something out of the video, and like I said, a few guys asked, and I thought I would talk about this, and but it's basically, like I said, it's basically verification with the dial bore gauge and measuring. This gauge reads in half thousandths, so this, as far as I'm concerned, is close enough for honing. Of course, my other stuff for rod fitment and pin fitting, and stuff like that, we're reading in line bores, we're reading in tenths of thousandths, and them gauges, I don't measure that kind of stuff in half thousandths. I like to be plus or minus a couple tenths on anything. If I can do zero, I'll do zero. That's it. Thanks for watching.